We know that there's this mysterious matter, this extra mass out there, but we can't quite put our finger on it. We don't know exactly what it is.
It's ghost matter. It doesn't glow, it doesn't reflect light, but it adds to the gravitating mass of objects.
From our very own backyard to the farthest reaches of the cosmic expanse, the universe is full of mysteries. Since time immemorial, it's been this way. Back in the day, those ancient stargazers were perplexed by comets and pondered over the secrets hidden within stars. New mysteries emerge from the shadows of the cosmos. And now, in today's video, we unravel the top 10 cosmic mysteries spanning the vastness of space and the depths of the universe itself. What caused the Big Bang? The question of what sparked the Big Bang is like poking a hornet's nest of ideas. Trying to trace back to a trigger for the Big Bang is akin to assuming there was a cosmic event that kick-started everything. But the notion of prior might not even apply in this mind-bending scenario. Picture this. The Big Bang wasn't just a grand event birthing matter and energy, it birthed space and time itself. Wrap your head around that. So, pondering a logical cause becomes a tangled web of speculation. Cosmologists, faced with this existential conundrum, have tried to sidestep the mind-bending idea of a universe popping out of thin air. Once upon a time, some folks thought our universe would crunch back into itself, only to explode again. Where did the moon come from? You'd think we'd have the origin of the moon figured out by now, especially since we've set foot on its surface. Yet, its origins remain a bit of a mystery. One leading theory suggests it formed from a colossal collision between Earth and a protoplanet around 4.5 billion years ago, with the debris eventually coalescing into the moon. Other ideas, like the moon being an asteroid captured by Earth's gravity, still float around. In truth, no one knows for sure. Is there life beyond Earth? The odds might seem astronomical, but given the sheer number of stars and planets out there, the possibility of life beyond Earth is tantalizingly plausible. Our observable universe boasts around 100 billion galaxies, each with billions of stars. Many of these stars host planets. Even if life arises on just one planet in a trillion, that still leaves about 1 billion life-bearing worlds out there. The big question, though, is whether we can find it. Within our own solar system, Mars, Europa, a moon of Jupiter, and Saturn's moon Enceladus all have environments that could potentially support microbial life. Discovering Martian bacteria, whether alive today or from the distant past, would revolutionize our understanding of life's prevalence in the universe. While no definitive evidence of extraterrestrial life has been found yet, Mars shows signs of having been warmer and wetter long ago, hinting at the possibility. Astronomers are also beginning to examine the atmospheres of distant exoplanets. A planet rich in oxygen and methane would be a strong indicator of life. For now, the existence of alien life remains an unproven hypothesis. Where is Planet 9? Pluto may not be a planet anymore, but that doesn't mean our solar system stops at 8 planets. Scientists are on the hunt for a 9th planet lurking somewhere in the far reaches of space. The odd orbits of distant objects like Uranus and Neptune hint at something mysterious. According to Konstantin Batygin, a planetary science professor at Caltech, the elusive Planet 9 inches is incredibly hard to spot. Batygin explains that even our best telescopes can barely catch a glimpse of it. What's antimatter? Antimatter is like a mirror image of regular matter, but with a twist. Each antimatter particle matches a particle of matter in mass, but carries the opposite electric charge, annihilating normal matter on contact. It's believed antimatter was created alongside matter after the Big Bang and still exists in the universe today. Scientists are baffled by its origins and behavior, but one thing's clear: we should keep our distance from it. What is dark matter? Dark matter is a shadowy presence in the universe, emitting no light or too little for us to see. Yet we know it's there because its gravitational pull affects the visible stars and galaxies. Take our Milky Way, for example. Without a huge amount of invisible matter adding extra gravity, it couldn't have formed all its stars in the 13.82 billion years since the Big Bang. The European Space Agency's Planck satellite revealed that dark matter makes up 26.8% of the universe's mass energy, while normal atomic matter only accounts for 4.5%. This means dark matter outweighs visible stars and galaxies by about 6 times. For years, scientists have pinned their hopes on weakly interacting massive particles, or WIMPs, as the primary dark matter particles. But despite their promising profile, WIMPs haven't shown up in the Large Hadron Collider near Geneva. Lately, attention has shifted to the axion, a super-light hypothetical subatomic particle. Strangely, no experiment on Earth has detected dark matter, despite decades of effort. This raises the possibility that it's not our understanding of matter that needs an overhaul, but our theory of gravity. Alternatively, dark matter might not be a simple fluid of one type of particle. It could be as complex as the atomic matter we see around us. Imagine a universe teeming with dark stars, dark planets, and perhaps even dark life. Did inflation really happen? While economists might think of inflation as rising prices, for cosmologists, it's a whole different ballgame. The theory of cosmic inflation proposes that the universe underwent a rapid, exponential expansion in its infancy. In a split second, the universe grew exponentially, doubling in size repeatedly before slowing down to the more measured expansion we see today. But did this cosmic growth spurt actually occur? The idea was a game-changer for cosmologists, providing a neat solution to the mystery of how the universe could be so uniform, even in regions that never interacted. The theory posits that our observable universe, which now spans 27 billion light-years, was once tiny enough for any irregularities to smooth out during this explosive growth phase. Inflation also accounts for the universe's seemingly flat geometry. Does time exist? Time is what stops everything from happening at once, said physicist John Wheeler. Yet, time remains one of the most elusive concepts we grapple with. Much of what we believe about it is likely wrong. We think of time as flowing, but flow implies movement relative to something else, like a river flowing past its banks. Does time flow relative to another kind of time? How time slices up for someone else depends on their speed and the gravity they experience. Space and time are intertwined into a single fabric known as space-time. Events from the Big Bang to the universe's end are laid out on this pre-existing four-dimensional map. Nothing truly moves through time. Imagine the universe's expansion in reverse, like a movie played backwards. In its earliest moments, space and time are torn apart. Physicists suspect that at the Big Bang, time emerged from something even more fundamental, but what that something is remains a mystery. Have more strange mysteries about the cosmos? Drop them in the comments below. If you enjoyed this, explore our other content. And don't forget to subscribe so you never miss out on more fascinating topics. Thanks for watching.